So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.
Welcome to this week's Energy Show. This week, we're talking about what to do in case of a blackout, particularly a defined blackout from your utility, a public safety power shutoff. Here's what PG&E sent to my home and almost all of our Silicon Valley customers. Quote, given the growing threat of extreme weather, we want all of our customers to be prepared for power outages. If elevated weather conditions, including potential fire risk, threaten a portion of the electric system serving your community, it will be necessary for us to turn off electricity in the interest of public safety. This is called a public safety power shutoff. We know how much our customers rely on electric service and want to work together to help you prepare for power outages. An important step you can take today, this is all from PG&E, determining if backup generation is right for you. This is what their suggestion is. A public safety power shutoff could impact any of our more than 3 million electric customers, including your home or business. Because elevated weather conditions can last several hours or days, we suggest preparing for outages that could last longer than 48 hours. Electric backup generators can keep the lights on, help appliances stay running, preserve perishable foods, and power essential equipment and electronics during a power outage. Generators can also pose safety hazards, so it is important to understand how to safely operate your generator before an emergency occurs. This means doing regular safety checks and being sure you have enough fuel to last a few days. All right, that's the end of PG&E's note. Basically, PG&E, Pacific Gas and Electric, recommends getting a gas generator. No mention on their website at all of a battery backup system. Simple reason, they don't want you to install solar or a battery since that reduces the revenues and profits. And they want you to buy a permanent natural gas generator because they can sell you natural gas forever. So here are your options as we go into fire season in California, now pretty much all year round. First, do nothing. Well, not necessarily nothing. Candles, flashlights, charge your phone from your car. Now, what's going to happen is food's going to melt in your freezer and your fridge. You're not going to have heat in the winter. You're not going to have hot water because your gas hot water heater usually uses electricity to start the fire. It's going to be like camping at home, and you're going to have a grumbling family. You'll probably survive, but you kind of really miss some of those necessities. Option 2. Get a temporary gas generator. It's a portable thing, $500 to $1,000 at a local hardware store. I've had one for over 20 years. Now, it's going to need gas. It's going to generate toxic fumes. Every year people die because they have the fumes from their generator go into their house. And it's very loud. I mean, it really makes a racket. So, like a small generator, you get a pull start thing, $300 to $500, maybe 1,000 to 3,000 watts, 120 volts. You're going to run a few things with extension cords. You run an extension cord to your fridge, things like that. You get a bigger generator, maybe $500 to $1,000. Sometimes they have battery starts, so you push a button, it starts. I had those. The battery would never be working, so I'd always have to still yank the cord. 3,000 watts to maybe 10,000 watts. You get over 10,000 watts, they're not so portable anymore. They have a 240 volt outlet, so you can power bigger things, but still going to run extension cords or wire in with a manual transfer switch. Now, next option, a permanent gas generator. These are natural gas generators that are plumbed into the gas utility line and wired into your house. $15,000 to $20,000 to $25,000 are expensive. They're going to power the whole house. Now, they depend on natural gas. When there's an earthquake, you're not going to have natural gas because the natural gas lines are down. Sometimes if there's a fire, the gas lines are out. And they're also going to need periodic maintenance and testing. Natural gas this is going to be expensive. They're going to require maintenance, but they do power the whole house, and they're somewhat noisy. So if you want to absolutely power your whole house, no blink, a plumbed-in natural gas generator is good. Now, it's still not going to work if there's like a really big disaster. The last option, this is what we recommend because it's simple and clean and portable, is a battery backup system connected to your solar. So the battery recharges with solar. These systems are available now from 2 or 3 major manufacturers. The battery charges back up every day from rooftop solar. They're dead silent, clean, they're reliable, And since it's solar and battery storage, you get a 30% tax credit and rebates from California. So the cost for these things are somewhere between $8,000 and $20,000 or more, depending on how much energy you want to store. So, if you don't want to be in the dark when PG&E pulls the plug in your neighborhood, and you don't want to get a gas generator, get a battery backup system. So, before we talk about the options, it's important to understand some of the technology, because the technology has an impact on the kind and the size of system you're going to get. You have to understand how much energy you're going to need. You're going to have to understand how much peak power you're going to need. And then you have some choices between an AC coupled system or a DC coupled system. And you have to figure out how it's going to integrate with your home electrical system. Your local solar contractor should be able to kind of help you with this, although they're going to be biased because they're going to try and point you in one direction or the other because they don't really have all the options. All right. First, important to understand energy, battery energy, just like the energy in your car battery or the energy in those little flashlight batteries. It's measured in kilowatt hours or watt hours. Now, a kilowatt hour is a measure of the capacity or the energy size of the battery, not the physical size, the amount of energy. And basically, it's the number of watts the battery can deliver over time. So a 10,000 kilowatt hour battery can deliver 10,000 watts of power for 1 hour. Or it can deliver 1,000 watts of power for 10 hours, more likely. More likely, you're going to be you're going to want to get like 500 watts of power for 20 hours, all right? And that's going to be plenty to run a fridge and lights and things like that for, a day, and then it recharges. All right, that's energy. Now, power is measured in watts. It's like horsepower. And by the way, 1 horsepower has 746 watts. So my old 71 horsepower VW Scirocco, a 30-year-old car, had a 71 horsepower, 65,000 watts. And my wife's Toyota has a 295 horsepower engine that puts out 220 kilowatt hours, 220,000 watts, 220 kilowatts. So now the thing is, the bigger the appliance at home, the bigger the motor, the bigger the wire that goes into it, the more watts it uses. So just starting kind of at the beginning, low end, the phone charger that we live by uses 3 watts, 2 watts, 3 watts, whatever, when it's charging. When it's not charging, it should be less than a half a watt. LED light bulbs, like a 65 watt equivalent LED light bulbs, is about 5 watts. Your refrigerator, when it's running, is about 500 watts. The refrigerator only runs maybe half the time or a third of the time, depending on how much you open it, depending on the ambient temperature. Now, when you're looking at bigger appliances, your central air conditioner, that big cylindrical thing you have outside, plus the fans in the house, that can pull 5,000 watts when it's running. So that's a big, big thing. All right? So you got to understand what you want to be powering. Now, we talked about the energy, we talked about the power. There's 2 generic kinds of battery backup systems, AC coupled and DC coupled. AC coupled systems are the simplest. The battery charges from AC power. Now, where do you get the AC power? The AC power comes from the electric grid, so as long as you've got power, you can keep your battery charged up. Or the AC power can come from your solar inverter. Remember, the solar inverter converts the DC on the roof, solar panels are DC, into AC, and then the AC output of that can charge your batteries. So essentially, the battery still charges from solar, but it goes indirectly through another inverter. And so if you have a AC coupled battery storage system, you're going to have one inverter for the backup and one inverter for the solar, 2 inverters. All right. And the good thing about these AC coupled systems is they can work with any existing system. Now, one downside is they're less efficient because they're about 90% efficient. The numbers go back and forth, but it's about 90%. Because every time you convert from DC to AC or AC to DC, you lose about 5%. So there's a 5% loss when you're going from the DC and the solar to the AC for battery charging. And then when you're sucking power out of that battery, you get another 5% loss when you go from the DC energy in the battery into the AC into your house. 5 plus 5, 90%. All right. They also typically have more complicated communications because you have 2 different inverters from 2 different manufacturers, 2 different monitoring systems. The monitoring is a pain in the neck, so it's more complicated. Now, DC coupled systems, on the other hand, are more elegant. In a DC coupled system, you have one inverter. And that one inverter has an input for the DC from the solar, and it has an input for the DC from the battery. And it can kind of take the DC from the solar, goes right into the battery, and then can take the DC power in the battery, convert it into AC for the house, or the solar DC, convert it into AC from the house. So one inverter connects to both of rooftop solar and battery. Both are DC. That's why it's DC coupled. It's about 5% more efficient, 95%, because the solar can charge the battery directly. When during the day, when your battery's low in the morning, the DC from the solar goes right into the battery, a lot of times at the same basic voltage. So you don't have to go back and forth between DC to AC, AC to DC. It's more efficient, more elegant, a little bit more complicated, but it's all in one box. The other thing that's good about these, in addition to being slightly more efficient, is you have one set of monitoring and communications. Whichever company's making this DC coupled system, they're going to have their monitoring system, and it's going to tell you what's going on with the solar. It's going to tell you what's going on with the battery. You can get an option even to figure out what's going on with the house. It's nice and elegant. Now, the inverter, like any new solar inverter, also has to meet the most recent rapid shutdown requirements. So that kind of limits you as far as inverter companies and limits you as far as choices. All right. Now, let's talk about the physical installation issues, right? These things aren't like, the size of a flashlight battery. The batteries are typically big. They're heavy. The LG Chem battery, which we've been installing for almost 2 years, is 214 pounds. This is a big thing that hangs on the wall. It takes 2 guys to lift up. The Tesla Powerwall is 251 pounds. It takes 3 big people to lift up or hang on the wall. There's some special equipment. They're both designed to mount on the wall, and some of them are also designed to be floor standing. You can mount the Tesla Powerwall on the floor. There's another new battery company called BYD. It works with SMA inverters. That thing can also be mounted on the floor. It can't be mounted on the wall. So you have to make sure that you have room on the floor in your garage or outside of your house, like, it's going to sit on a concrete area like your air conditioner, or on the wall. You need some wall space for a battery and the other components. You're also going to need a transfer switch or a backup power unit. So that kind of goes between the house and the grid, and the solar and the grid, and the backup system in the grid. You'll need a backup sub panel. We talked about these things on other shows. You'll need an auto transformer, and you may need a special meter. Okay, we talked about energy and we talk about watts. You got to figure out how much energy you need and how much power you need during a blackout. So let's look at the energy requirements of stuff you have around the house. Your fridge. Average fridge might use 2 kilowatt hours of energy a day. Your heating system. The gas furnace might draw 600 watts. Let's say that maybe uses a kilowatt hour a day if you're going to turn the thermostat down and not use it too fast. Lighting, maybe half a kilowatt hour a day. Internet, TV, other toys you got, a kilowatt hour a day. Dishwasher, 1.5 kilowatt hours a day. Hey, you know what? Probably could buy a few days with just washing dishes by hand, so you might get away with that. So total of less than about 8 kilowatt hours a day for a typical house if you're not going crazy. So a 10 kilowatt hour battery is good enough if you're careful with your energy usage. And keep in mind, the next day, the battery is going to recharge if there's sun, and it's going to partially recharge if it's cloudy. So as long as it's not completely overcast, you're going to get some juice out of that battery. All right, that's energy. Power requirements. The backup systems on the market are usually limited by the inverter or the battery power output. They can't put out 10,000 watts at once without kind of shortening the life of the battery or just frying the inverter. Most of them are limited to about 7,000 watts, and that sounds like a lot. It's good for all the small appliances, but it's hard to run anything that's going to draw 240 volts, anything that has a lot of wire going to it, like air conditioning, well pumps, electric stoves or ovens, or your electric dryer. Now, some systems can be doubled up, and you can actually get that much power. It's nice to have for a short blackout. But there's a hidden problem, and I'm sorry that so many people are putting these things in to power their air conditioner. We even got a call from somebody else today that wants to run his air conditioner. Let's say you're running this with this big battery system, and you're powering your central air conditioner, and that requires 5,000 watts when it's running. Then you get a blackout, and you don't know there's a blackout. Everything's going to keep running. Well, your air conditioner is running on a hot day, and if that air conditioner, 5,000 watts, runs for 3 hours on off, 3 hours that day, you've sucked out 15,000 kilowatt hours. You've blown through the capacity of one battery and you're into the next one. You're not going to have any power for anything else. Power's out at night or maybe later in the day. And now your fridge is going to start melting. You're basically out of juice. So we strongly recommend not to power large appliances. Don't run your air conditioner. Don't try and power your electric oven. Don't try and power your electric dryer. Save your battery energy for smaller appliances, the essential things you need. Okay, that's our advice on how to design and size a system. Currently, there's 3 good mainstream options for battery backup systems that I'm kind of comfortable with. SolarEdge, Tesla, and SMA. Now, these are inverter companies or inverter and battery companies, and the inverters are usually the brains of the system. Now, there's lots of other good companies out there. Off the top of my head, Enphase, they've been around forever. I love Enphase. They don't have a backup system yet. Sonnen was recently bought by Shell, another company called Pika, another called Electric IQ, and a bunch of other startups. So I'm going to focus on the market leaders with the broadest geographical coverage and a really good track record. So number 1 in my mind is SolarEdge combined with LG Chem. LG Chem, huge battery company. I mean, they make the batteries for my Chevy Volt. It's a DC coupled system, so you only need one inverter. One inverter does solar and it does backup. You can use either the LG Chem battery, and there's an option where you can use the new BYD battery. BYD battery is kind of cool. It's got a little more capacity. It's not wall mounted. BYD is the biggest manufacturer of batteries in the world, and they make electric vehicles in China. Now, the SolarEdge inverter has a built-in backup control unit. It's a transfer switch. You do need an external transformer and a meter, and you'll obviously, as with all of these systems, need an external backup subpanel. We've talked about that before. And with the investment tax credit that applies for these battery backup systems connected to solar and the rebate from California, the price for this system, incremental to solar, is about $8,000 to $10,000. So if you're putting in solar, $8,000 to $10,000 more to put in this backup system. One limitation is the capacity is limited to 25 amps. It's not going to back up your whole house, just your critical loads. We have customers that said, I'm going to just turn the circuits off of my other appliances. It never works. What happens is they forget, there's a blackout, the inverter keeps trying to turn on, off. It just can't hit it. There might straw, they might have 3 refrigerators or an air conditioner. It just fails. So you always have to design it to make sure you're powering the critical loads. It's good because it's DC coupled. That means it's 95% efficient. The solar charges the battery directly, and it's the best choice for new solar systems if you want to add a battery to. I also like it because the monitoring is relatively simple. One company, SolarEdge, provides the monitoring to the solar and the battery in your house. It's nice. All right. Another good option is the Tesla Powerwall. That's an AC coupled system, and they have the Tesla Powerwall battery. It has an integrated inverter, and you can use multiple Powerwalls. I don't know, maybe 5 or 10 units. It's kind of crazy. Now, keep in mind, though, you're going to also need an existing solar inverter. So not a great choice for somebody that's saying, I want solar and backup power, because you need 2 inverters. It's redundant. You will need a backup subpanel, and the price with the investment tax credit and the rebates about $14,000 to $20,000. I look on the Tesla website. They're selling the Powerwalls with the installation for about $20,000. That's including installation, and that's for actually 2 Powerwalls. They say it can power the whole house, but with the caveat that you might be powering the whole house for 2 hours and then boom, nothing's working in the house. And since it's AC coupled, about 90% efficient. It's good for existing solar systems. It's more expensive for new systems, and it's got more complicated monitoring. Tesla has monitoring, and if you have like an SMA or a Fronius or an Enphase inverter, you're going to have separate monitoring from those companies. All right, third option, which is pretty new guys on the block. SMA, historically one of the biggest inverter companies in the world, is teamed up with BYD, big Chinese battery company, and they also offer the LG Chem battery. So this SMA system is new, and SMA's got the reports are really, it's like the Mercedes of inverters. They have a nice battery backup inverter with a control unit, and it's AC coupled. So if you have an existing solar system, if it's SMA, if it's Enphase, if it's Fronius, this is a really good choice. The battery and the battery inverter and the backup unit are all separate. So you've got a separate battery, BYD or LG Chem. You have a backup power inverter from SMA, and you have a control unit from SMA. Very well designed. Now, keep in mind, you're also going to have your solar inverter. And that could be a bunch of Enphase panels, or it could be a SunPower system. Who knows? All right. Now, keep in mind that this thing is AC coupled, so it's 90% efficient. You're not charging the battery directly from solar. You're going from DC to AC and AC to DC. But it can power the whole house. It's got a built-in capacity for 200 amps. That's how much current can go through the thing. Keep in mind, though, that it's still only limited to about 30 amps. So you're not going to be able to power your air conditioner for more than a few hours if that's really what you want to do. The price with the investment tax credit and the rebates, about $13,000 to $20,000. So it's kind of a pricey add-on, but if you have existing solar, in my view, this is one of the two best options. All right. Now, also keep in mind, you're going to have two separate monitoring systems. The monitoring system that came with your solar, let's say it was Enphase, and the monitoring system that came with your SMA inverter. All right. So here's the reality. Public safety power shutoffs are coming. Gee, I think that like PG&E has been our marketing department recently because they're really, really scaring people. And by the way, I'm doing the show in the middle of July. They're already having some of these rolling blackouts. It's not going to get any better. On top of the usual weather and equipment failure blackouts, we're going to get more and more of these. The utility's not magically going to become more reliable. So here are my recommendations. It's pretty easy. It's the choices, to me at least, if I were a homeowner saying, what should I get? Based on our testing and based on our experience, the choices are pretty easy. And also keep in mind that we're at generation 1 with this equipment. And it's not perfect. The communications aren't going to be perfect. And since it's generation 1, that's why I think it's really important to make sure you buy from a major manufacturer. All right. So if you're shopping for a new solar and storage system, you say, okay, I'm finally going to get off my butt and put in solar. I'd recommend the SolarEdge DC coupled battery backup system. It's most cost effective. It's going to be the most reliable. You got one inverter, one set of communications, state-of-the-art rapid shutdown capabilities. It's kind of a little technicality, but you need it. Now, if you have an existing system, if you have an existing SolarEdge system, that's pretty much what we've been installing for the last few years. It's pretty straightforward to update your inverter with a StorageEdge inverter, and many of our customers already have that. It's DC coupled. You'll have one inverter. It'll be more efficient, simplest and most efficient solution. If you have an older solar system with, say, Enphase or SMA or SunPower or Fronius, you really at that point have two choices. Tesla Powerwall or the SMA Sunny Boy backup system. Both SMA and Tesla are good, about the same price. I don't have experience with Tesla, but I've got good experience with SMA. It's been pretty reliable. Okay, that's all the time we have on this week's Energy Show. Thanks to all of our listeners for tuning in. And if you missed any of today's show, you can go to our website at cinnamon.energy and listen to the podcasts.
So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.